Hey everyone, it's Sean. Welcome back to the channel. What I have in front of me is a SounDigital EvoX or EvoX, I guess. See, 800.4 appears to be the model number. 2 times 4 ohm speaker output. We're looking at 200 to 234 watt, barring the input voltage 12.5 to 14.4 volts. Hey, I look at this from the side. We have our ground REM 12 volt source over here. Oh, my camera needs to get flipped. Why don't we do that? Transition. No, that's not it. Transform. And boom, there we go. But anyways, this comes via a customer who says no work key. So we're going to try to power it up first and verify what problems we have. Okay, so what I've done is I've currently got my benchtop DC power supply. We'll see it over here. It is set to 12.15 volts. We're already drawing about 127 milliamps, and I don't even have the REM triggered. That seems like that doesn't seem right to me. We'll probably have a short in the power supply section. It did initially ramp up about 900 milliamps, so almost 1 amp. Let's trigger the REM. I've got my oscilloscope set to DC level, and we're going to slowly bring this up to see if we can trigger this guy to turn on. Yeah, triggers on right about 8 volts. Okay. So I do have a blue light over here. We are powered up. Let me get my multimeter. I want to check to see if we have any DC on the inputs or outputs. Okay. Oh, speaker output, I'll go to the ground over here. Let's see. Not seeing anything. Let me go between the terminals we have here specifically. All right, so in that regard, I'm not seeing any DC, so that's good. Let me see. Got anything on the input? No, nothing on the input whatsoever. Okay, so now I'm going to feed an audio signal into this to see if we get an output. Give me a second. So here's what I've done. Okay, power supply still hooked up. Again, we're only drawing about 130 milliamps right now. I've got a 80 hertz tone at 1 volt peak to peak going into this input you see right here. Okay. Let me move these over because I think these correspond to the inputs. Put this one here and that one there. Okay. And the output going to the speaker, I'm not hearing anything, but on our oscilloscope, we can see that 80 hertz signal at 1.12 volts peak to peak. Okay. So I'll move my oscilloscope probe off the input. Now, I don't know how the signal is split at the output going to the speaker. I don't know if one side is actually a speaker ground, the other one's passing a full sinusoidal waveform, amplified waveform. I don't know if that's how it works, or if it splits it between the negative and the positive with their own polarities that get combined at the physical speaker over here. So for the interim period, all I'm going to do is just touch my oscope probe to the speaker. I'm not going to use the ground probe whatsoever. And yeah, let's increase the amplitude. I've gone from 1 volt to 2 volts to 10 volts. Yeah, I'm not seeing anything out of the speaker or out to the speaker at this point. Let's see, we can increase the gain for that channel. Nothing. Yeah, absolutely nothing. So we probably have a dead driver, dead output MOSFETs. You know, this is mostly just a guess for right now. Let me move to this channel. Yeah, nothing there. Just to make sure, I'm going to go through all 4 channels. Yeah, nothing anywhere close to there. Let me go to the other side. Gotta be super careful not to touch the DC because I don't want to pop my speaker. Okay, I'll do this again. Yeah, no output whatsoever. Okay, so at this point, I'm going to tear this down and we'll take a closer look to the input of everything with the amp taken apart. Power applied, no input audio going in. The only thing on this thing that is really getting, you know, any type of heat whatsoever is this board to the back side of here. It's getting a little warm, not excessive. That could indicate where we have an issue. Could, or it could be a red herring. So the best thing for me to do at this point is kind of research the components in here and see if I can trace audio through the amplifier and figure out where our issue may be. Well, the first thing I'm going to check is the input stage, preamp stage at all 4 input channels. What you have at the input are these TL074C DT op amps. Okay, they're 14 pin, and I'll just go over the second one in a row here, so that's where I'm currently connected. And yeah, I am getting something on the oscope. Let me go back, and my oscope seems to have timed out. Hold on a second. Hey, we'll try this again. Might have been because I was knocking around some cables, but yeah. So the preamp stage on that channel seems to be good. Well, we only have 2 that are providing an output. Oddly enough, I think we have a input voltage issue here as well. So 12 volts on this side, I would assume things are duplicated over for 12 volts or maybe a negative 12 volt rail on the other side. But beyond that voltage, we have, let's see, channel 1 does not have an output. Channel 2 will have an output from its preamp side, which we could most definitely see. Let me get this recording. All right, if I go to that cap right there, you can see the output. Each one of these has its own op amp. Only channel 2 and channel 4 appear to be providing an output at their op amps. I don't know if that's because maybe that, here goes channel 4. You can see it right there. I put 800 hertz into it just so I could trace out with my toner versus 80. That frequency is too high. It would get cut out at the dis-end, so it'd be substantially attenuated, to say the least. So yeah, no output for channel 1 and channel 3. And it appears that none of them has given us an output at the speaker as well. So I need to tear this down further and start probing some components. So I do want to show at least one other thing before I tear anything else down. Visual inspection of the board. Looking at this side over here, and I got this lovely warning: do not try to copy our exclusive design, or you will face the consequences. Hey, I'm not going to copy any design. I'm just going to repair your design, so I think we'll be good. We got components. This was the side where we had the excessive heat. Okay. And if we look at these components down in here, just by the side, ooh, we got one that's burned up. Now, if that's our entire issue, I'm not too sure yet. Looks like we have a preamp issue. This might be the driver or something going to the actual amplifier section, not the preamp section. I am slightly concerned whether or not we will be able to find what these components are, because when I look across the PCB over to the side over here, you can see what we have. These are probably the amplifier ICs, those right there and there. You can see that the tops have been scrubbed off to obfuscate what integrated circuit it is. So this might be somewhat of a pain to repair and maybe not worth it. But I'll dig down. I think what I'll end up doing is I'll take this side off first, because this is an obvious failure right there. And we'll work on that, and then from there probably work on the preamp side if there continues to be an issue with it. Well, you ready to see what I see? Bum, bum, bum. Bum, bum, bum. All the carnage. Blown in channel MOSFETs. Bum, bum, bum. Good news is all these are procurable. They're all 4 of them IRF 40R207 in channel MOSFETs. You can get them from Mauser or DigiKey. Yeah, they SAMP was overdriven. I'll have to check these diodes and these transistors or voltage regulators. 5B here, 5B there, just in case the resistors. I'm gonna check them out as well, but yeah, let's get those replaced. That explains why at power up, even without the trigger being on, that we're drawing some current. That could be the reason why I'm getting one of my voltages are missing. But here's my concern though, and let me drop this off to the side so y'all can see exactly what I'm seeing. Now, really, you see where these were pressed against this transformer here. Really, ignore the fact I smashed my finger pretty bad in the door of my Jeep not long ago. There goes ugly finger. Anyways, you can see we're in these in-channel MOSFETs gave up the ghost. They blew out. They have exposed the side of this transformer, really you would need some kind of insulation layer, I believe, to isolate. And if you're using this as kind of like a heat sink, you need something to provide a bit more insulation or isolation, I would think. And then down, it's kind of gone. I already kind of sweeped out underneath there. But you can see carbon deposits all the way down through the bottom underneath the transformer. And I've already kind of taken you can see it's pretty apparent right there in the center. Kind of taking a cotton swab, and just try to clean up down there a little bit. So I don't know the condition of the components that are underneath this transformer, if they're bad as well. But at the very least, and they don't look blown. Nothing looks blown down in there. At the very least, I'll try to go through here with a multimeter and check diodes and stuff. But yeah, for right now, let's get those in channels on order and then see where we go from there. Hopefully, it's just the in channels. Hopefully, no bigger issue with the preamp side of things. Maybe it's just that voltage is missing that's causing those other channels to go out. So we are going to get those in-channel MOSFETs on order and see if that hopefully repairs this guy for us. Again, the word is hope. All right, let me get those on order. I'll come back once we have work to do. Well, I have in the parts needed in order to, there goes a part number if you'd like to write it down. Let's see, there we go. In order to replace all the in-channel MOSFETs on this board, you can see that they're all very, very much not in good condition. I've tested the other components on the board. I don't think that there's any other issue with this, but you know, with it removed, I do need to check to see if we still are missing voltages on the board, because that could indicate a problem elsewhere. Hopefully not with the transformer, because if there's a problem with the transformer, we're done at this point. So I'm going to power this up, and we're going to use my multimeter to see if the positive and negative 5-volt rails are back with this board removed. All right, so I have my power supply set to 12 volts DC current turned up a little bit. I'm using my SiC generator to set another DC output level. We're going to take it up to, let's turn it on there at 7. Take it up to 10 volts. We can see that the amp has turned on. I'm drawing 0.027 amps, so 27 milliamps. I'm going to take my multimeter. Now, I know that we have a positive and negative 5-volt rail here on the board with test points. And yeah, going from ground to positive and ground to the negative test point, they're not there. As a matter of fact, here on this PCB, this very first pin over here should be like the positive or negative rail. This one should be a positive or negative rail as well. Okay. Now, something else I know is our 12 volts should hit the back side of this, or a little low, that transistor right there, which means that I should see 12 volts show up right here. Oh, and that's not good. So I get 12 volts, but only when this is powered down, not when it's powered up. That tripped my SIGGEN. It detected an overvoltage and turned the output off. So there's something causing the too much current flow to ground. And so measuring that voltage across This PCB is not good. All right. So what I need to do at this point is determine, is this board right here bad, or is this board over here bad? And maybe we get our voltages back. I'm not too sure. I don't need that condition where I also check 12 volts here and see that it's dropped there. I need to find where the issue is at. So I think what I'll do is I'll start off by desoldering this board first, because it's going to be a lot easier to desolder, even though there's a plate and everything else. And then I'll power this up and check some voltages again. Several minutes later, I have it desoldered from the board. Not powered up yet, but yeah, you know, fully powered up. But our 12 volts is there, and no other voltage rails. Let's try to power it up again to see if we get the same weird condition. I don't want to do this 12 volt test too many times, but we'll, nope, no positive, no negative voltage rail. And yeah, that shuts us off again. So the issue is not with that board. I wonder if the issue is going to be with this board over here, or if we have other issues somewhere else across this PCB. I'm not sure. So I think the next step I'm going to do is just kind of trace around the board a little bit and then remove basically the driver ICs, I think, sitting over on this side, and see if we have our plus and minus voltage rails returned to us. All right, now with this driver PCB, or whatever we want to call it, removed, I'm going to go ahead and check these voltages one more time to see if they'll be there. And let's see, can we still turn it on? And we can. Okay. Still drawing about 0.028 amps. That's 28 milliamps. Measuring DC. Is my 5 volt rail back? Nope. And nope. And then is this going to shut it off? Yes, it does. So the problem is going to be somewhere on this board, and that's where now I need to start focusing my attention. Well, with the transformer removed, I'm able to get a better look underneath here. We do have like a voltage type regulation IC. What is it? A regulator pulse width modulator SG2525A, SG3525AP, exactly. So that might be causing the issue we're having. I think it's very possible that it is. When I power up the supply, turn it on, definitely no longer, at least with the transformer removed, it's no longer tripping off when I measure between here and the 12 volt. Obviously my 5 volts is still not there. Still nothing here. All right, so there's one output that leads to this pin here, and that gives us about 5 volts. Here, I'll do like this. And output B also shows 5 volts. Whether or not that is good, I don't know yet. Need to look at some data sheet, but I think my issue is predominantly in here. Hopefully it's not the transformer. I don't think it's the transformer, but yeah, I'm gonna get that replaced, get that guy over there replaced, do a little more digging. I also noticed that when I turn this off, let me put it over to resistance. There is, here goes a 22K resistor measuring about 18K. Okay. This one over here is supposed to be like 120K. And it's like, that's really weird. Like there's a capacitor that's charging up. I'm gonna remove that one and test it. But yeah, I think the problem is gonna be over here, and I could probably go ahead and purchase this IC. Maybe that resistor there. It's kind of weird. I'll probably check these caps here as well, and then go from there. Well, off camera, I went ahead and replaced the IC. Never mind my nasty finger here that I smashed in a door a while back. Replace that IC. I've put the transformer back on, and then I've rebuilt this board back here with our N-channel MOSFETs, as well as the 10 ohm resistors on it were all reading high, some around 100, some 200, some up in the K. So those all got replaced. As far as the N-channel MOSFETs go, here is the part number that I use for them. You see 942 IRF 40R207. Here goes the 10 ohm resistors that I use. Let's see, part number 71T MPW060310R0FEEA. I've got some left. These are 603 size SMD resistors. And then, of course, the actual IC. Give me 1 second. Here we go. It is part number 511-SG3525 Alpha Papa. You see it right there. Well, I've got everything set up to begin testing. I think the first thing we need to do is power it on to see if we've got all of our voltage rails. Okay, so let me first do that. We'll get it powered up. Okay, it is powered up. And let's see. Can I get my multimeter into the shot? Somewhere over here. Let me move this out of the way. There we go. Turn that light somewhat out of the way. All right. Do we have our +5 and -5 voltage rail? That's really what I care about. Yes, we got our -5 and we've got our +5. So I'm good there. I think with that, I think I'll just go ahead and get a tone into here and we'll check the outputs with my oscilloscope. All right, going to check each channel. We'll start with channel 1. And channel 1, I have got 24, 25. Yeah, we got an output. Let me increase a little bit. So I'm taking it up to what, 33, 34. Okay, let me go over to channel 3. Yeah, 32. We're pretty close in amplitude between the two, so I'm going to say that that's okay. If I bump it down, still controls 22. Let me go back to channel 1. And 23, 24. All right, let me go to channel 3. Channel 3 and channel 4 are both controlled together, so yeah, we got amplitude. We got a AC waveform on channel 3 at 27. Let's take it up to 30, 31, 32. Let's see if that goes over to channel 4. And yeah, 31, 32. Yeah, it seems to be tracking pretty well. So hey, we got output on all 4 channels. I'm going to call this one repaired. We're also, for record keeping, from my bench power supply, drawing 0.9 amps So I feel like we're pretty good there. 12.5 volts is what I have set up. We're drawing 997, almost 1 amp. So that's probably nominal for this. We'll call it good. So let's see. Let's recap. We had blown output MOSFET board, not just the in-channel MOSFETs, but the 10 ohm resistors were bad on it. We were missing our plus and minus voltage rail. We replaced the IC down there, got everything back together and tested, and it is good to go. So if you enjoyed this repair video, please let me know by leaving a comment in the description below. And like this video if you enjoyed watching it too. If you're new to this channel, subscribe. Why not? You're already here. That all being said, I'm going to get this cleaned up and back to the customer. Take care and goodbye. Bart?